Okay, I think we'll get started. So, hi everyone, I'm Nicole from Primary Engineer, and welcome to our online interview today. And this one's featuring Narlen Mahabeer, who is previously a design engineer and is now a reward consultant at the Weir Group. Before we get started, I'll quickly run through what's going to happen during this session. So, the first part of the event is Narlen's presentation, and that will be followed by a Q&A section. So please feel free to type in any of your questions at any point during the session. And then at roughly 1/4 we can get straight to answering them as many as possible. So what is the If You're an Engineer, What Would You Do competition? The main aim is to inspire young people ages 3 to 19 to look at the world around them and start designing some solutions to problems. So this can be something as simple as making toast or getting dressed, or even worldwide problems like pollution or plastic waste. We provide opportunities for you to meet and interview professionals online, just like we're doing today with Narlen, to inspire you to think of ideas and start designing some inventions. So without further ado, I'm going to hand over to Narlen and I'll stop sharing. You should be able to.
Thanks, Nicole. I'm just going to pull up my slides now. Nicole, just checking if it's sharing.
Yeah, that's perfect.
Wonderful. Thanks again, Nicole. Thanks to everybody who's just joined us now, and thanks to Primary Engineer for this opportunity to speak with you all a little bit today. I figured that a whole lot of other engineers are going to speak to you about how they found themselves into an engineering career. And I know a few other engineers from the company that I'm working at are going to talk to you about technical design engineering, research and development, and disruptive engineering technologies. So I figured you're going to get quite a bit of that already, and I'd try and provide a different context if you'd like. Over the last few years, I found myself going through a number of different roles in the organization that I work in, and I thought I would share how an underpinning engineering background and an engineering skill set has helped me navigate through a number of different jobs, and just how really transferable an engineering skill set can be. So let's get into it. I'm Narlen Mahabeer. I'm a mechanical engineer, graduated from the University of Witwatersrand in South Africa. I joined the Weir Group in the year 2017, and thus began my journey within the company over a series of roles. And like I just mentioned a while ago, I'll talk to you how I've navigated those roles through an application of different engineering skills, or I perceive skills that I've acquired through an engineering background and qualification. So that's what we'll spend a little bit of time talking about. And to do that, I just want to provide some context to the company and the business and the industry that we are involved in. And the Weir Group is a Scottish company that is celebrating its 150th year of operations this year. It started in the 1800s as a company that was providing some pumping technology to the shipping industry out of the Clyde River shipyards, and has evolved over time to support a number of different socioeconomic needs and worldwide business needs and requirements. In the 1900s, we found ourselves producing aircrafts and aircraft engines because there was a demand for that at the time. But over the last century, or the last half of a century, we've been very much geared towards a pure play mining company. And where there's mining, there is a lot of engineering taking place. And just to show you a global map of the operations and the coverage of our company, we have over 11,000 colleagues in over 60 countries across the world, and this really covers the largest mining areas across the world. And naturally, the company being like this meant that there were a number of opportunities for young bidding engineers such as myself to navigate through the company and try out different jobs and different experiences. So that's a little bit about the company and where we're at. And we are pretty much based in the mining industry. We support that industry. Mines across the world are our customers. And what do mines do? Mines are basically these naturally occurring deposits of minerals in the ground. There are parts and there are pockets of the world where we have naturally occurring minerals such as copper, gold, platinum, etc. And they're there in the ground. And we have a demand to use some of those materials and those minerals. Why? Because those materials are quite useful to us. Through the current electrification and hybridization of the world, with the world trying to shift away from using non-renewable energy sources, we find that there's a big demand for these minerals such as copper and gold and platinum, because the technology that supports renewable energy is really developed on some of the naturally occurring materials such as copper, gold, and platinum, etc. So we in the Weir Group, we try to help the mines extract those minerals from the ground. And we do that in these 4 processes here. Number 1, extraction. So we're involved here. We help the mines dig out big boulders. We help them break up the surface of the ground so that they can start extracting big boulders which have the minerals inside it. So we engineer those products. Comminution, this is where we start providing a series of machines and products to help the customers now take these massive boulders and we help them crush and grind and separate that material. So if you're thinking about mining this way, you're trying to get that mineral from the ground, but you're starting off with this big boulder and you need to break it down into smaller pieces until you can separate that mineral from the ground. And comminution is a stage of the mining process where you're crushing and grinding the large boulders into smaller particles. So we design a lot of the machines that facilitate this process. And I can assure you that there is a lot of highly specific and detailed engineering going on here. While it may not appear to be as extravagant as the Formula One industry, which is what inspired me to study engineering, some of the machines we design are incredibly complex, and we design them to run at extremely tough applications, and it's absolutely fascinating. So once we've crushed and ground some of the material to smaller particles, we try and transport them to different parts of the mines. And the best way to do that is to take the crushed material and mix it with water, and you put it in a pump, and the pump will take the material somewhere else to the mine. And now the mine can start doing some interesting chemical and process work to start separating the mineral from that mixture of water and particles. So we design and manufacture a lot of the products that facilitate that process as well, which is called the mill circuit. And you can consider the last part of the process as tailings management. Your tailings in a mine is basically the waste product at the end of the process. It's the discarded material that needs to be treated before it can be safely released back into the environment. But mines have been telling us that, you know what, there's still actually some minerals there. We still have some copper and some gold in there. So we started developing some technology to help the mines extract some of that leftover mineral from the tailings. So basically, we're an organization that help mines extract minerals from the ground. And I gave you that context about mining and Weir just to help you understand how my jobs across Weir have had a part to play in all of this. So my jobs, I graduated in the year 2016, and in the year 2017, I started work in a graduate engineering program, and I was a design engineer. So I was taking that theoretical knowledge that I acquired in university, all that mechanical engineering expertise, all that theoretical understanding of all the subjects that I've studied, and learned how to apply it to product design. So we had to design products to facilitate the process that I was just described to you a little bit earlier. So what did I do then? In that engineering role, I was calling on the following engineering skills. I noticed that engineers needed to have an analytical mindset. They needed to be able to perform detailed designs and detailed calculations and analyses. So I was calling on that engineering skill there. Engineers are described as problem solvers. So minds would often phone us and describe a unique situation that they need our help and support on. The design engineer's role there was to create a solution and problem solve and basically alleviate the problem for them. So there was a lot of problem solving involved in that role. And I think engineers, from the training that they get in university and within their careers, develop excellent problem solving skills. So in the engineering role, a bit of problem solving. But what I liked most about the design engineering role was getting to work across the organization, particularly those areas involved in the product lifecycle. So what's the product lifecycle? It's basically end-to-end process of how the product comes to life to when it's safely disposed. If I had to give you an example, if a customer has a brand new requirement if a mine requires a solution, there's some upfront design engineering work required to help the mine understand what does that solution look like. If the mine is happy with that solution, then the design engineering team can develop the detailed design engineering, the detailed designs of the product. And if that's approved by the mine and they're happy with it, then the design engineer produces a set of drawings or a rubric or some design specifications to instruct a manufacturing facility to be able to manufacture that design. And importantly, to the specifications of the designer. So the designer has had some interaction with the mine, is now going to have some interaction with those that are manufacturing the parts. So it's actually useful for the design engineer to know about manufacturing processes, and that can include casting steel, it can include molding rubber, it can include cutting and grinding, and it can include a number of different manufacturing processes. And once it's manufactured, it gets tested to make sure it's safe. And once it gets into the customer site, sometimes the design engineer has some interaction with the customer to ensure that it's fit for purpose, it's exactly as it was designed. And yes, that's my favorite part about the design engineering role. It was so centric to the product lifecycle, and I think a perfect starting point for a young budding engineer to learn about engineering as a whole, to learn about networking and working with customers and understanding how engineering principles are absolutely essential in the manufacturing of products and solutions. So that was job number one. I spent about more than a year on that. So quite obviously calling on engineering skills. Job number two, within the same department, I rotated to work in the production line in our company for a little while. So I mentioned earlier, once we design the product, we send it out for production. It has to get manufactured. I worked a little bit on that production line to ensure that we were providing engineering expertise to that production line. And that required supporting them, troubleshooting issues, and all of that. I was calling on the skills of having attention to detail. I think this is an engineering skill, finding a root cause of a problem and helping them investigate it. teamwork and collaboration, again, it's working with quality teams, with manufacturing teams, ensuring that the mine is going to get a highly engineered product made to our specifications, high quality. And a lot of analytical skills, again, are being used here, because if there are some design issues, then it was up to me to call that out to our design team that I was formerly working with, and making sure that they fix the designs to ensure that we sort the issue and it doesn't happen again. So two very obvious engineering roles using engineering skills, I'd say. After that, I had an opportunity to move to Scotland for 6 months, where our head office is based. And there I was managing a project that was not an engineering project. This was a project on working culture, on employee engagement and working environments. It was trying to understand, what does a culture look like in an organization? How can we put a number to that? How can we analyze that? And how can we use that information to make some positive changes? Now, that's not an engineering job typically, but I took it on because I was excited at the prospect of it. So what skills was I using to execute that role? Is definitely project management. And this is something that I studied in my engineering curriculum. Project management is a logical sequencing of events to make sure the project is successful. What needs to happen? What needs to happen after that? What happens after that? How can we ensure that the project's going to be met? What are the risks? And just having a good logical understanding of what's required to make a project to go well. Something I think engineers have a good natural affinity to. So I was calling on that quite a lot. Also, I found myself calling on a lot of my analytical capabilities. We now had a massive data set to tell us what working culture looked like in our company. So I took that raw data and transformed it into useful management information so that senior leaders in our company could start making some strategic decisions. And of course, because this project was global, I had to work across the entire company and project manage a team that was based all over the world, from Artarmon in Sydney in Australia, which is 11 hours ahead of me, to Portland in Oregon in the States, which is 8 hours behind me. So massive spectrum there, just time zones alone. But it was incredibly interesting and a very worthwhile project. But I did it by breaking down the project into a problem and tried to solve the problem just as if it was an engineering problem. After that role, I led a reward project, and I'll talk about reward in just a second. And that was to design something called a job architecture. Basically, it's what jobs do we have in our company? What do they do? And can we describe them in a framework that says, this is this job, this is how it interacts with them, and this is what level it sits in the organization. This was a massive project that usually takes a company about 2 years to do, but we had to do it in a much shorter period of time. And the skills that I was calling upon was, again, teamwork and collaboration, working across a global team. Again, it was project management, understanding the necessary steps required to ensure successful project delivery. And the analytical piece here was to extensively understand every single job in our company, what they do, what are their biggest complexities, how they partner with others, what happens if the job doesn't exist. And we could then form a very solid framework that is now being used to develop a lot of strategic thinking and a lot of organizational projects to build off of. That was arguably my most complex project to date. And but I found myself calling on skills and capabilities that I developed through my engineering career to execute that. And since then, I've joined the reward team at Weir, and basically reward is this. It's a strategic area where where it's a strategic. It's a strategy of how you attract and retain your workforce, and that's done through a number of ways. You can do that by, you have to consider the compensation, the remuneration, and that includes the cash that they get, but it also includes the non-cash elements, the benefits that they're entitled to. This can include shares within the company. It's a strategy to ensure fair and competitive pay for employees. It's a strategy to ensure well-being for all employees, and this is financial well-being, this is physical well-being, this is mental well-being. So quite a lot of those elements to try and figure out a way to making sure that your company is attracting the right people and keeping them, and making sure that you're doing it fairly and competitively. So it's a very different job to what I've done before, but I was excited at the prospect of giving it a go. And I still find myself calling on the skills that I've described to you previously. I'm still calling on my analytical capabilities to make sure that we're using our information that we have and basing fair decisions on it. I still have attention to detail. I'm still using my project management capabilities to ensure that whatever projects we're running are still going to be done on time and successfully. And whenever unique issues or problems come up, we use the same process of problem solving, that is, simply break down the problem to something that you can understand and understand what your solution is required to do, what's limiting you, and what's your criteria for selecting a solution. And applying all of these core engineering skills have helped me thus far in each of my roles. And that's really me. That's about 4.5 years of experience through about 5 different jobs. And hopefully you've seen me applying a different number of engineering skills that I've called on from my engineering background and engineering qualifications. And I don't have anything further to share with all of you. So I think I'll hand back over to Nicole and ask her if she's spotted any questions in the chat box.
Okay, well, thank you for that, Narlen. That was really interesting. So I just want to remind everyone that if you've got any questions at all, there's a Q&A facility at the bottom of the screen. So yeah, please feel free to type in. We already have a couple. So Rachel asked quite early on, does it harm the earth when you take copper or gold from it?
Harm the earth? That's a good question. No. Thankfully, mining has been developed over hundreds of years now. It's been a process developed over time. So as you can imagine, they've figured out how to do things safely, how to do things sustainably to make sure that they're extracting the right amounts of material. But no, they're not harming the earth. They're barely scratching the surface of the earth, actually. And they're taking, well, there's a lot of, put it this way, there's a lot of international standards in place governed by some very senior organizations across the world to ensure that whatever mining is done across the world conforms to very strict standards, and every operating mine in the world has to adhere to them. They have to do it safely, and the standards are ensuring that that the environment is not harmed throughout the process. So hopefully everybody, all the mines are following all of these processes and guidelines in place. But no, it's done within, if it's done within the right guidelines and all of that, then there should not be any harm to the environment.
Mm-hmm. And South Hetton Primary School has asked, are there many women engineers in your company and also within, the reward consultant team?
Okay, engineering first. Right. I did mechanical engineering, and I'll take this back a step. In my university, I would say 10 to 20% of the students were women, which is not a good number at all. And when we graduated, it was about the similar proportion of males to females. At the workplace, I still find a very disproportionate relationship between males and females within this industry. It's been like this for a very, very long time, unfortunately. And part of this is hopefully trying to inspire some women and some females and uh, young people around there that this is not a male-dominated industry. It is a male-dominated industry, but it doesn't need to be. And this is not a gender-based job by any stretch of the imagination. Some of my friends, some of the best engineers I know are women, and they've proven the fact that anybody can do the job. And in fact, in the company that I work in, I'm an inclusion and diversity ambassador, trying to work across the board to ensure that we're putting the right attention to this, to make sure that we're promoting engineering as a career to males and females alike, and trying to ensure that our hiring processes are fair to all genders. But no, unfortunately, the industry is still quite male dominated. But hopefully we can start to make some inroads in that.
Mm-hmm. And Mel has also asked, what was your favorite thing that you've ever made or that has been made by another engineer?
That's a good one. There's so many. Favorite thing that I made was, it may not impress you, but it impressed me quite a bit. So I took a combination of about three of the products that we make in our company, and I put them together in one solution. And I was really proud of that. And it was a project for a university. The university wanted to show their students how to separate materials, and I designed a solution that took about at least 3 of our products, and it worked quite nicely, and it became a practical means for that university to illustrate some engineering practices using our products. And yeah, I was involved with it throughout the end-to-end process, from the upfront designing to the manufacturing of it, ensuring that they made it to spec, that it was made properly, and then we sent it over to the university for them to use it. And I heard that it was going quite nicely, but no, I haven't checked in with them for quite a while. But that was the nicest thing that I made. But other people have made some absolutely extraordinary things. Just down the road from us in Todmorden in England, we've got an additive manufacturing facility that's basically 3D printing. And we're starting to research ways that we can use 3D printing technology to replace conventional manufacturing, which is casting steel and then grinding it and polishing it and putting it in the machine and taking off. So you basically make a big material and then you shape it to what you need, and that's called subtractive manufacturing. 3D printing is a whole different ball game, is where you build up to the required specifications, and it's incredibly complex but so incredibly fascinating at the same time. Mm-hmm. I think some of the additive manufacturing products that were made were those that I thought were incredibly innovative and interesting, but there's loads more.
So do you think that 3D printing is, part of the future for engineering?
Yes, it's a whole different ball game. It provides opportunities where we didn't really see there were opportunities to go into, because it's a build up manufacturing sort of process. We can start to look at manufacturing completely differently, because if you cast steel, you've got a solid material, which is really heavy, and heavy is generally not good in engineering. Heavy means expensive, a lot of cost to that. With 3D printing, you can create this fibrous structure, which is a lot lighter, but in some applications maintains the structural integrity that you would have in a pure solid manufacturing process. And in those instances, 3D printing wins. So yes, it's definitely a challenge for design engineers across the world to see how disruptive technologies such as that can be embedded in their own design processes to ensure that they are keeping abreast of the technology. And it is definitely a way of the future, that's for sure.
Okay, so we're kind of running out of time. We've got a couple more questions. So again, South Hetton has asked, how much copper can be found in a day?
Oh, I can't remember that, unfortunately. It really does depend on the size of the mine. It was a ridiculous number. Tell you what, Nicole, if you could grab the details of the person who asked the question, I can check and come back to them. I honestly cannot remember. It's been a couple of years since I've been on a mine, but it was something extremely impressive in the tons.
Yeah. So yeah, I'll find those details and I'll get in contact with them for that. So another one from Mel. Are you going to work to help stop climate change or at least reduce it?
So in my role, not so much, but I can help. What was the question directed at me or the company, really?
I suppose the company.
Yeah. Okay. Well, a bit of both. Yes, we've got a very ambitious sustainability target put in place where we're trying to achieve net zero emissions by a certain period and reduce our CO2 emissions by half by a certain period. And it's absolutely incredible the amount of work that they put into place at the moment. And if there are opportunities to get into that, then I would do my very best, because that, I think, one of the questions that I was trying to preempt was, if I was in this challenge, what would I do? And it would be something along the lines of, how can we start thinking in a way to offset our global carbon dioxide footprint? We know we've got a worldwide issue. What can we start doing? Personally, you can start making some small changes within your own home. Make sure you're recycling properly, making sure you're using the right light bulbs and sort of things. But there's bigger, more transformative things that we as a company can do in our manufacturing processes. And we're looking into that in a lot of detail. And we've set ourselves some really ambitious targets to do that. And if there's opportunities for me to try and support that in any way as possible, then yes, I would do to the best of my ability. Yep.
Okay, well, we've run out of time. So I hope it's really, really informative for everyone that's been watching. Thank you all for joining us. And thank you, Narlen, for your presentation and answering so perfectly.
It's a pleasure. Thanks so much.
So yeah, we'll end it there. If you want to get any more information, then you can go to the www.leadersaward.com website, and there's lots of different resources on there that you can get involved with. But yeah, thank you again. Thank you for taking time out of your day, Narlen.
No, it's an absolute pleasure. I just hope it was of some value to everyone that was listening.
Definitely was. Okay, well, thank you. I'm going to end it there. Thank you.
All right. Bye, everybody.
Bye-bye.